Okay, we're in section 13.1, and in this section my goal is to teach you how to use the rectangular coordinate system, a gift to us from a Frenchman named René Descartes. His little invention revolutionized science and, by extension, our daily lives. René Descartes lived from about 1596 to 1650. And his little invention, he did much more than just this, but is the horizontal and vertical axis system called the XY plane. It's a way of finding location on a plane or plotting points. The x-axis measures the horizontal distance, left and right, and the positive direction is always considered to be the right-hand direction. Okay. The up and down distance is measured by the y-axis, and the positive direction there is always up. So the first one I mentioned, the x-axis, is the first one that's listed. Your x coordinate number is listed first, and it tells you how far left and right to move, and your y coordinate tells you the up and down. Now you have to have a place to start, and the place is located here where point B is, and that point is called the origin. And since to originate means to start, that makes sense that it would be called the origin. I'll start by highlighting this point up here. Its coordinates are x equals 3 and y equals 5. Now, since both of those are positive, you can be moving from the origin in the right-hand direction first, and then the upward direction second. So 3 to the right, and 5 spaces up, and you land right on top of that point. It's as simple as that. You have to simply keep track of the x-coordinate first, which is left and right. So the first coordinate always tells you left or right. This next one right here, you got to move to the left 5 spaces and then 1 space up. So you can see its coordinates are -1 for the 5 spaces left, and then +1 for the movement 1 space up. We have one more here. If you move 4 to the right, but then you don't go anywhere up or down, you just move to the right, its location would be 4, 0. And you can see that the y-coordinate, more on this later, the y-coordinate is 0 when you're on the x-axis. All right, so we have 5 points, 6 points actually, listed here that their location is shown, but their coordinates are not. So point A is 3 to the left and 3.5 up. So we go 3 to the left by saying -3, and then you follow that up with 3.5 up. That would be a +3.5. Point B, we've already mentioned, is at the origin, which means it's that you don't have to move anywhere, neither up nor down, nor right nor left. It's at the origin itself, and the origin is always 0, 0. So its coordinates are 0, 0. Point C is 5 units to the right and 4 units down. So by the convention of right being positive, you go 5 first, positive, and then down 4. And you got to keep track of these positives and negatives. Up is positive, right is positive, and the x-coordinate always comes first, so you always are interested in right and left before you're interested in the up and down. Okay, point D, you're going to the left 4 and then down 5. To the left 4 and down 5, and you can see that in this part of the graph here, since you're going to the left and down, both coordinates have to be negative. Okay, point E is simply 3 down. So you don't go anywhere right and left, but you go 3 down. And I'm going to point out while I'm here that the x-coordinate is 0 when you're on the y-axis. So the x-coordinate is 0 when you're on the y-axis, and earlier we saw this one here where the y equals 0 when you're on the x-axis. All right, finally point F, and its location is a little ambiguous. We have to decide an estimate here. How far to the right would that be? Well, it looks like about 1.8 to the right, and I would guess about 4.1 or 2 down. So those are guesses, but we'll go with 1.8. and negative 4.2. Obviously, I didn't leave enough room there to put those coordinates. Okay, now in this next exercise, we're just going the other direction. They give us the coordinates, and we have to locate the points. So point A is 5 to the left and 1 up. So let me locate point A. There's point A. Point B has an x-coordinate that's 0 and a y-coordinate that's 4. And that means you don't go anywhere left and right, but you do go up 4. So there's point B. Point C is 1 to the right and 6 down. So we're down there for point C. And I'm helping you with these lines. Normally you would just put the point itself. So let me back up here. There's point C. And I'll use highlighter on point D. 6 to the left and 1 up. So from the origin, you march 6 spaces to the left and 1 up. All right, E has a y-coordinate that's 0, so that means we'll be on the x-axis. And in fact, when the x is negative 2, it means you move 2 to the left. So there's point E. And I'll slow motion F. 1 to the right. And 1 down. So here's the location for point F. Okay, now you might notice that the x-axis and the y-axis, you should label them. I once had a teacher that marked me wrong for a whole quarter's worth of correspondence work because I didn't mark those x and y axes like that. I was very bitter. All right, the x and y axis divide the plane into 4 sections. They're called quadrants, and they're labeled from the top right being quadrant 1. You'll notice I'm going to be using Roman numerals here, and you should always do so. Quadrant 1 is the quadrant you're in if the x is positive and the y is also positive, in other words, to the right and up. Then you go counterclockwise for quadrants 2, 3, and 4. The Roman numeral 4 is IV, and it's the one that's to the right for the x, so positive, and negative for the y because it's down. So you can see I've highlighted that the x will be positive and the y will be negative. Okay, there are locations that are on neither or none of the quadrants. They're the ones that are actually on the x and y axis, and we've already highlighted these. If the x-coordinate is 0, for instance, back here would be, if the x-coordinate would be 0, for instance, down here is 0 to the right and left, but 3 down, then when the x-coordinate is 0, you're actually on the y-axis. You can see it's on the y-axis. And vice versa. When the y-coordinate is 0, when the y-coordinate is 0, you're on the x-axis. And please notice that that is a flip. When you want to be on the x-axis, you have to set the y equal to 0. And when you want to be on the y-axis, you have to set the x equal to 0. Okay, so let's find out where these next points are, and I'll continue after example 2 on the next video. But what we have here is which of the quadrants would these 6 points lie in here? Starting with the 2 that are on the x and y axis. All right, when the y is 0, you're on the x-axis. And maybe you can picture this. That would be 2 to the left of the origin, which puts you square on the x-axis. And when the x is equal to 0, then you're on the y-axis. And maybe you can picture 0, 4. It'd be 0 right and left, but 4 up. And that's definitely on the y-axis. Okay, point A is to the left and up, which puts you in quadrant 2. Let me remind you of the other quadrants. It goes 1 in the top right, and then counterclockwise in order from there. Point C is to the right and down, which puts you in the fourth quadrant. And if you're starting at the origin going to the left and up, that puts you in quadrant 2. We already had one in quadrant 2. You'll notice that both A and D have a negative for the X and a positive for the Y. And point F, you're going to be one to the right and one down. So if you go to the right and down, it puts you in quadrant 4. Actually, I think I'll continue this video here for the next couple of problems. Okay, if you've got a pair of coordinates, x and y, that satisfy a given equation, here we got an equation x and y add up to 10. If they make the equation true, they're said to be solutions of the equation. So true or false, 3 plus 7 equals 10. Well, that would be true, so we have a solution here. 5 plus 5 adds up to 10. There's another solution. 7 and 3, x and y values, they add up to 10. I should point out that 3, 7 and 7, 3 are different locations. One is 3 to the right and 7 up, and the other is 7 to the right and 3 up. 4 and 8 do not add up to 10, and the x and y coordinates in this one here add up to 11, so we do not count that as a solution. But if you add negative 2, 12, that works. I'll continue with circling them when they work. And 0, 10 works, and so does 15, negative 5. If you add those together, you get 10. All right, so let's take these 6 points to the next problem here and see what happens. 3, 7. I mentioned that that's not the same as 7, 3, and you'll see that in a minute. 5, 5. 7, 3. Okay, here's the one I said is different. 7, 3. Yep. 7, 3 and 3, 7 are in different locations. Negative 2, 12 would be 2 to the left and 12 up. 0, 10 would be no right and left motion, but a y value of 10. The y values go on this axis, and the x values go on that axis. And finally, 15, negative 5 would be way down there. And you can see pretty quickly here that we have a pattern going. These are all lining up in a straight line, and that means that x plus y, mathematician would say this is a linear equation since its graph is a line. So let's connect these, and you can see straight line works perfect through there. And you'll have to excuse me as I move this around a bit. But there we go. There's the linear equation. X plus y equals 10. There's millions of other points on that line that also work. For instance, 2, 8 works, and so does 8, 2. Let's go with 13, negative 3. 13, negative 3. If you add this x and this y, it adds up to 10. And we could continue in this fashion for millions of other points, which would not only connect the ones we have, but fill in these arrowheads, meaning it goes on forever in each direction. So there's your first example of a linear equation on a Cartesian, named after René Descartes, XY plane. And we'll continue in the next video with example 5.